Uh, Good morning or good afternoon, depending on where everybody is. We're going to go ahead and let people continue to join. We'll give people a few minutes to do that. But while we're letting people continue to log on, I'm just going to go through a few housekeeping items, and that way people can not miss too much of the presentation when they log on. So right now, everyone except for the panelists is muted. And so if you need to communicate with us, please use the chat box. If you can't see the chat box, just pull out the little orange tab in the upper right-hand corner of your screen, and you can type a question, or if you have any technical issues, we've got somebody doing tech support for us back here. Also, we will be taking questions at the end of the presentation, but again, you can submit those questions at any time by typing them into the chat box. And we are recording the webinar, so if you want to see any of the information later on, or if you miss any of it, or you want to contact any of our presenters, you'll be able to access the slides and a recording tomorrow on the SSTI website, which is ssti.us. And again, for anyone joining us late, everyone is muted except for our panelists, but you can type in your questions by typing them into the chat box. We will be taking questions at the end of the presentation, so go ahead and type those in as they occur to you, and we'll leave some time at the end to do questions. So if any of you are not familiar with SSTI, we are a network of reform-minded state DOTs. We were founded in 2010 and we're housed at the University of Wisconsin. You can see the states that we're working with right now, and that changes a little depending on what the interests of the heads of the DOTs are. And we work in three ways. We do work with the executive level at the DOTs as a community of practice so they can share information and ideas. We do technical assistance for the states that we're working with and then share that with pretty much anyone. And we are a resource for the larger transportation community, and do things such as our webinars, our resources on our website, and our newsletter, which comes out every 2 weeks. And again, all of this can be accessed at ssti.us, which is our website. So joining us today are Chad Tucker, who is the Assistant Administrator in the Division of Transportation and Mobility Planning at the Virginia DOT. He is the person who pretty much oversaw the ranking of projects for their smart scale project prioritization at VDOT. And he'll tell you a little bit about why accessibility was important to Virginia DOT. And then we'll be hearing from Dan Hardy, who is a principal at Renaissance Planning. Renaissance was contracted to do the accessibility rankings for Virginia DOT. And then finally, Matt Pettit, who is a product applications engineer at Citilabs, and he can talk a little bit about the software that they used, which is Sugar Access. And if anyone needs a primer on accessibility and Sugar Access in general, we did have a webinar in March, which is again available on our website, ssti.us. So if you want to go back and take a look at that, it'll give you some more in-depth information on Sugar Access and the idea of accessibility in general. So I am going to go ahead and turn over the keyboard and mouse to Chad, and he can go ahead and start with his presentation. Take it away.
Muted.
All right, thank you, Robbie. All right, the first thing I thought I would do is just take a couple of minutes and give y'all a little bit of background on what Smart Scale is, and you know, sort of how it came to be, and the thought process behind, you know, how we created it and what we wanted to focus on. So it actually was a bipartisan effort between our governor, and who was a Democratic and Republican Speaker of the House, sort of came together and really recognized that we needed to have a more objective, performance-based approach to how we selected projects for funding in Virginia. So there were a series of bills that were passed related to that, which really charged our Commonwealth Transportation Board with developing a process. And it laid out some loose parameters to sort of guide the development. It took us about 16 months to develop it, and there was quite an extensive amount of stakeholder outreach with respect to working with cities, counties, and towns in Virginia, as well as our regional planning partners, transit organizations, metropolitan planning organizations, to get their input on what was important to them, to provide feedback on the different weighting that we wanted to apply, because we didn't want to treat projects in really dense urban areas, would have a different weighting than, say, a project in a rural area, so be sensitive to the needs of different communities in that area. So the overarching goals were, we wanted to focus on expected or anticipated outcomes of the projects, as opposed to measuring how bad the problem was. So what is the project going to bring to the traveling public if it were implemented, and base our scoring off of that. One of the other goals was to provide some stability to our 6-year improvement program, or our capital improvement program. We were very overextended from a programming standpoint. The cost to complete projects that were in there would eat up funding for the next 15 or 20 years. So you'd have a little bit of seed money that would be put on a project to start PE, and then you would wait for right away. And it just was a very inefficient way of conducting business. And so the thought was, run it through an objective process, and if it gets funded, it gets fully funded for all the phases, and we are able to quickly implement the project and get the benefits out to the public. And then also establish a better link between our statewide and regional planning processes and the programming process. So our initial direction was, everyone wanted it to be very easy to understand, so very simple and straightforward, not make it too technical, not require applicants to have to invest a significant amount of time applying for projects, so they, not having to hire an army of consultants, if you will, to put in their project ideas to have them scored. And then really VDOT and our sister agency, the Department of Rail and Public Transportation, be available to provide technical support in project scoping, compiling needed data that we would need to evaluate the projects later on. Another big success was going the direction of having a web-based portal for applicants, cities, counties, towns, MPOs, transit organizations to be able to submit their projects and manage their grant applications. And so I've provided a link here if you're interested in sort of seeing the portal that is used to submit project applications, but that really helped streamline things, because we could get data in a consistent format. We didn't have to rekey it into our systems to conduct the analysis. So some of the guiding principles, let's analyze what matters to people and what's going to have a meaningful impact from a transportation standpoint. Try to be as fair and objective as we can with respect to the benefits, but also the benefits related to the cost. So you might have a project that has a tremendous amount of benefit, but it's also a very, very expensive project. So by normalizing to the cost of the project, it allows smaller projects that are more targeted, that may not have as big of an impact, to compete with larger, say, mega projects. Make it transparent and understandable, make it a process that works across the Commonwealth. We have very rural areas of the state, as well as extremely urban areas of the state. And another unique characteristic is all modes are submitted and evaluated against one another. So highway improvements, highway widenings compete with bike ped improvements, with rail transit and bus transit. So all the modes go into the same process and are evaluated the same way. And that really guided how we selected the measures, because they had to be mode agnostic, if you will, and work across the different modes. and try to our best of our ability to minimize some of the overlap in the different measures. You know, we've gone through 2 cycles of the smart scale process. Some of the benefits that I've seen is it definitely is improving transparency in the decision-making process and bringing more accountability to the project selection and project development process. I think it also is forcing folks to rethink their solutions and do, if you will, some value engineering or value planning on their improvements. So we've seen multiple benefits come out of this, more focus on multimodal solutions as opposed to one-mode solutions. So I wanted to give you all a real quick overview of kind of the general framework and what measures we look at, but spend the majority of the time allowing Dan and them to explain exactly how we measure accessibility. So there's 6 factor areas that we look at. We look at safety, congestion, accessibility, economic development, environmental quality, and then land use. But land use is only applicable to the urban areas. This is a breakdown of those same factor areas and what particular measure are we looking at or scoring projects on. So you'll see there, you know, for safety, we look both at the reduction in the total anticipated reduction in the number of fatal and injury crashes and also the reduction in the rate. So there's a little bit of balance there between the urban and rural. For congestion, you've got your increase in person throughput as well as your decrease in person hours of delay. And then here for accessibility, the 2 that I've highlighted there are really the access to jobs. And we've got 2 measures there. One is access to all jobs for all people, and then another measure of access to jobs for disadvantaged persons. And one of the main reasons we have accessibility as a standalone factor area with these particular measures is, say, for like congestion mitigation on delay. You might have a 3-mile improvement that you're making to an interstate facility, and you're going to increase speeds by 15%. But what does that do to the traveling public? And really, we make transportation investments in order to improve access to opportunities and access to activity centers. And that's really what the 2 measures here are looking to do. What is that increase in speed or that reduction in delay? How many more jobs can people now get to improve their opportunities in life? And also there's the benefit on the employer side. You're anticipating a bigger access to a larger block of potential employees or labor pool. So there's benefits there in how projects are increasing access to these job opportunities, the benefits, you know, that has to economic development. And we initially in round 1 and round 2 focused on job access increase, but as Dan will go over here later on, some of the future enhancements that we're working on is really access to all sorts of activities. It could be access to educational opportunities, access to healthcare, access to parks and recreation. We do envision this particular measure sort of becoming more robust over time and looking at how are our transportation investments potentially going to increase accessibility to different types of activity centers throughout the state. We've got the environmental quality measure and then economic development and land use. So how we actually go about scoring, just real quickly, is each measure we calculate for each of the projects, and whoever has the best or the best measure value, in the case of, you know, say delay, the highest amount of delay reduction, that project would get a score of 100 for that particular measure, and then everybody else is prorated off of that. So the example you see on the left side, you know, the highest values of 500, that gets a score of 100 for that measure, and then everybody else is sort of prorated as a percentage of that highest value. So if a score changes, you know, during our QC process, if one of the scores below the highest value changes, it really only affects that one score. But if part of a QC we determine, you know, we made a mistake and the highest value is impacted, then it's really going to permeate through the entire scoring process and everybody would get readjusted. So that's just an important way of understanding how our scoring process works for each of the different measures. Now, where the weighting comes into play is how we actually weight the different factor areas. So, as I mentioned earlier, we did a lot of outreach throughout the Commonwealth and allowed the regions to provide input on what they felt was important in their areas. So you'll see here, Northern Virginia, Fredericksburg region, and Hampton Roads, which are three of our most urban areas in the Commonwealth, really put a premium on congestion mitigation and on land use and accessibility. Conversely, in area type D, which would be your very rural areas, they put more weight on economic development and safety. So this weighting scenario allows us to be sensitive to the desires and really what drives transportation decisions throughout a wide range of different area types in Virginia. So and that weighting comes into play with respect to, and here's an example or a portion of one of our scorecards. You've got the measure value there beside measure value, and then right below that, that's the normalized value, 0 to 100. So you can see this project did really well on land use, did pretty good in one of the environmental factor areas. And then you've got each of the measure weights, the weight within that factor is consistent across the four area types. Where the area type weighting is down there about the fifth row up is when we apply the factor weight. That all comes down into the overall project benefit score. And then we've got the smart scale cost. And what the smart scale cost is how much money are they asking for? So you could have an applicant has a $50 million total cost for an improvement, but they're only asking for $20 million of that. And they're going to leverage regional funding sources or local funding sources to cover the remainder. So that smart scale cost is how much money are they requesting from the state. And then the smart scale score, the official score that's used for project selection, is that benefit score divided by the cost. And what you'll see is very often when you look at that smart scale score, it's projects that are less than $10 million are sort of at the top. And it might be a very targeted intersection improvement, that's addressing a safety issue. So, smaller projects actually can compete fairly well in this project. So that's just a general sort of overview of what smart scale is and
unmuted.
The different factor areas we look at, and then Dan's going to get more into the weeds from a methodological standpoint, specifically how we're measuring that.
Okay, thanks, Chad. And I also did want to mention that if anyone wants more information on Smart Scale, we did have a webinar back in July of last year that was about the first round of rankings for Smart Scale. So there's a whole webinar on that if you really want to dig into that, and Chad was on that as well. So Dan, you should be able to go ahead and proceed.
All right, great. Thanks,
Muted.
Robbie. And talking about the smart scale accessibility approach, I'm kind of providing the bridge here between the policy and the detailed analysis. And as many of you know, one of the goals that we have in transportation planning is to use data, turn that data into information, turn that information into wisdom. And it's been really exciting to be part of this project, in part because, as Chad pointed out, there's been a lot of work at the front end and top down. We're all standing on the shoulders of giants here in terms of how to take and inform decision makers about the best use of funds to put into place good projects that really help folks connect where they are with where they want to go. And we're using really good data and tools, and Matt's going to get into that in a little bit, but I'm going to kind of provide that bridge, if you will, between the policy and the detailed data. I'm going to talk a little bit about some background about how Smart Scale is thinking about accessibility, In particular, focusing on the multimodal approaches. As Chad said, one of the keys was to make sure that all projects in all areas of the state are able to be evaluated on a level playing field. And this is the second year we've gone through this, as Chad noted. We've also got some ideas as we go through this process in terms of future opportunities, both within the smart scale approach as well as other ways that the state of Virginia and partners at the region and local levels can be thinking about using accessibility. So again, a little bit of a primer probably for those of you who were in the last webinar a month ago, but basically accessibility is a very flexible way of looking at the world, and it really is composed of a land use component and a travel component. For the purposes of smart scale, we were looking at the land use component being the number of jobs from each household in the state. We're looking at the travel component as being a travel time, and one of the policy decisions was to let's look at a 45-minute maximum auto or 60-minute transit travel time. And then one of the key things is considering distance decay in looking at how easily you can make connections between all the starting points, in this case being jobs, and being households, and all the ending points possible, in this case being jobs, with that separate connection of looking at disadvantaged populations and scoring them separately. And what we've used in terms of data sources here, a couple of key things to point out here is that we did look at a 2025 scenario. You are trying to evaluate the effect of projects that won't get built. You're just starting to get the funding ready to put them into place. So looking at a near-term future in terms of what that benefit would be in terms of jobs, looking at some very robust data sources in terms of the HERE, or it used to be called NAVTech network. I'm going to talk a little bit more on the pedestrian side about the comfort index and using the best available data on transit operations. And the decay at the very bottom there, again, we'll come back to this a couple times, is that's based on the National Household Travel Survey information about how people actually decide what opportunities they're going to avail themselves of on a daily basis. One thing that we always struggle with a little bit is the best way to present what does accessibility really mean. And if we had a very simple place of only 15 places to start from and go to, what we're doing in Smart Scale is starting off with existing accessibility and really looking at using sugar to say from zone 1 to all the other zones within 45 minutes for auto, how many jobs can I get to and what time does it take? And in this case, maybe those easternmost cells are beyond our 45-minute window, so you get a 0 and you get a value for different levels for each of those cells. You then basically go on to the next origin and look again at what are all of the travel times and jobs I can get to for all those destinations, and you continue that process, and it's usually more than 15, thousands upon thousands of blocks or block groups for this analysis. The key here too also is that then we're weighting by the population, so that if cell 1 had 1,000 households and cell 2 had only 500 households, cell 1 would count the job accessibility. Cell 1 would count twice as much as for cell 2. That's starting off with this no build. We then go back and look at the same thing with the improvement that we're trying to gauge. And so again, starting in zone 1, it's possible you've got a project that lets you get from zone 1 now within 45 minutes to those eastern cells. You've got to change from zone 1 to everywhere. You then see what's my change from zone 2 to everywhere. And once again, you go ahead and add that all up, do a weighting by population, and now you're able to see what was the change in accessibility by mode to jobs, both for everybody and then for the disadvantaged population. I'll take a step back a little bit. That what's on the title here says VTrans, and that's the shorthand terminology for the Commonwealth of Virginia's long-range plan for transportation. And this was some of the work looking at Richmond as an example of just the kind of patterns you see in terms of, again, how you can, from different places, in this case, the Richmond region, get to jobs by different modes. One thing to point out is that the scales on these 3 modal maps are different. In each case, it's about a 10-to-1 ratio. But on the auto accessibility map, you'll see kind of a standard. You can immediately identify the core of the Richmond region, and you can see the hot purple going out pretty much along radial routes where there's a good auto access. Transit, you get the same kind of pattern, but obviously it's much more concentrated on the downtown where the transit system operates. And one of the big kind of ahas here, I think, was that for walk access, again, maybe only 1/10 of the jobs you can get to in transit because people walk a lot slower than they get on a bus or get in a car. But the message being that pedestrian accessibility really is important in a lot of places, that there are many areas throughout almost any given region where there are great walk opportunities. And so connecting people to places is not just about downtown urban areas. Another kind of big picture message, this time thinking about that role of distance decay. Most of you are probably familiar with accessibility in general, and the fact that what we're doing in a way is looking at the gravity model. And I always think it's kind of interesting that if you look at the Hampton Roads region in Virginia, at the area where the Chesapeake Bay meets the ocean, gravity modeling goes back about 35 million years, when an asteroid slammed into the southern end of the Chesapeake Bay and created the kind of circular area there between the Delmarva Peninsula on the upper right and the cities of Newport News and Hampton and Norfolk on the southern part. And that affected the way the York and James River flowed into the bay and created a region, Hampton Roads, because of the then roads was the term for waterways that connected these communities. And on the left side, we see what is often a more traditional way of looking at accessibility and just saying how many jobs from each starting point can I get to within a 45-minute commute by auto. And then on the right side, we see what is that when we consider distance decay, which recognizes the fact that because some people will not travel more than 20 minutes, some people will travel an hour. Looking at that set of travel patterns within the National Household Transportation Survey, we're able to see that if you are starting, for instance, in the northern peninsula there in the city of Newport News, you've really got to get to the jobs on the south side, you've got to invest first in a 15-minute crossing of the James River. So that right there makes a big difference between what you might think you can get to in terms of just plain jobs versus what you can get to if you're considering the value of those jobs that are near you having a higher value than those that are 45 minutes away. So it helps change the perception a little bit of what the value of connecting people to places is in terms of accessibility. A second way of kind of thinking about this is the term of art that we used was catchment area. And for each project, wherever it was in the state, we were looking at what was the benefit, who might benefit from that project. And it seems probably pretty intuitive that a huge project is going to have a larger area of benefit than a smaller project. But we were also very cognizant of two things. One, as Chad mentioned, the idea of trying to keep a balance between smaller regions, more in those the more rural areas of the state, in contrast with larger regions such as Washington, D.C. area, Richmond, and the Hampton Roads area. And the second one being that we are using census geographies to look at the basis of the analysis, and that often in smaller regions you have larger blocks or block groups, both by geographic area in terms of acreage, and sometimes even in terms of population, or you'll have smaller population block groups in more rural areas. A term of art we didn't really put in the final designation, though, for this catchment area was those circles that are on this cartoon graphic are a 45-mile radius circle, and I think of that as being like a Roomba. If you think of the little vacuum cleaner that runs around and covers a circle, we're basically taking that circle, defining an area, and moving that around the state, including an area 45 miles outside the state of Virginia, to look at jobs that people living in Virginia could reach outside Virginia. And that helps normalize for region size and boundaries. It means you don't have to be stuck on, I'm at the edge of a region, what happens? We're looking at a continuum that crosses regional boundaries. And that kind of weighted average that I mentioned of looking at the population weighting helps address that block size variation that you get in different parts of the state. Last kind of big picture thinking about how this got applied was in looking at decay curves. And so again, we had decay curves for autos, for transit, for pedestrians, and we've looked at work trips and non-work trips, but focused for smart scale on the work trips. And one of the big findings was, as we looked at the household travel survey, that the graphic here shows the different types of decay curves that we get. Again, the right side is what's the amount of travel time that people report in the NHTS that they travel to work by auto. On the left side is then a cumulative percentage of what percentage of people will travel a certain amount of time. So the right curve is actually the Washington, D.C. region. We found has a very distinct travel pattern curve, so that, for instance, the 60% of the people traveling will travel more than 20 minutes on that blue curve, but 60% of the people elsewhere in the state are traveling more than about 10 or 12 minutes. And we found that generally throughout the state there was a common auto decay curve, but it was distinctly different in Northern Virginia and the DC region. And again, trying to reflect what the benefits are to the people who are already in a given area. We used a separate curve for North Virginia, separate from the rest of the state. Kind of moving to the output, a couple of examples here. One of them is just looking in general about the accessibility increase. And one of the projects that did score fairly well in terms of accessibility was in Fairfax County, Virginia, Fairfax County Parkway, and an interchange with arterial called Pope's Head Road. And there's two graphics here on this screen that show you what's happening in terms of the output of the measurement of project accessibility increases. On the right side of the chart is that kind of concept of the Roomba. Again, that blue area is the catchment area, with the red dot being the location of the project in the center of the area. And that, again, is an area about the size of Connecticut that centers on a project. On the left side is a graphic that shows both the job density and the development or activity density and diversity in terms of jobs and housing for the Washington, D.C. region, where the height of the bar represents the density on the ground, with downtown D.C. being the center and the area where the area density is the greatest, and the color being jobs, housing, balance. And so again, the tall spikes in downtown D.C. are red because downtown D.C. is very jobs heavy. Most of the area around it, like many regions, is a sea of low density blue residential, surrounded by more mottled colored and a few areas of increased density and diversity. And this particular project is, the green area on that left chart is the Fairfax County itself. In this project, we are kind of at the edge of where the blue meets the red in Fairfax County. So we're right at the edge of the I-66 corridor in the Fair Oaks area of Virginia. And so on the right graphic, what you're seeing is orange to the south and east of that, because that's where the greatest number of people live and are able to get through what is now a pretty significant choke point along the Fairfax County Parkway, signalized intersection on a road that is largely grade separated interchanges. And they're trying to get mostly north into the I-66 corridor. There are also benefits for folks that live on the north side because this is the Fairfax County Parkway is a circumferential roadway, and are trying to head to the southeast, but not that benefit's a little bit lesser. And you can see, like throwing a rock into a pond and watching the ripples go out, that the farther away you get from that project, the less benefits you have for the folks throughout that catchment area. And when you get to the edges, there are no benefits at all. So that's kind of a little illustrative in terms of what we're doing in looking at the benefit of a given project on accessibility. Chad also mentioned that congestion mitigation is one of the other objectives being considered, one of the more traditional objectives that folks have looked at for a long time. How quickly can I move? And then accessibility adds to that. What can I get to when I'm moving more quickly? And so it was really important to be looking at what we expected to see was a indirect relationship between the time savings that the projects provide in the congestion mitigation index and the accessibility to places that would show up in our work. And Chad also pointed out that the way each of these scoring systems work is that the top scoring project gets 100 points on a scale, and all of the other projects are proportionally given points that reflect that top scoring project. That does a great thing in terms of helping again, normalize effects. So if you're not measuring everything on the same metric, but you're allowing those metrics to float a little bit and looking at relative performance of projects, it does create a real strong responsibility in the quality control process. We want all these numbers to be perfect, of course, but with 400 projects, the most important thing is to make sure that we know why we have outliers. If there are outliers that are setting that definition of the best project, it's really important that that project be the best project. So this chart was looking at, on the x-axis, what was that information coming out of the congestion analysis that we were using as inputs to accessibility. And on the y-axis, we're looking at what was the increase in the number of jobs accessible by a project. And again, useful check on time savings. The size of the circle here is actually looking at the total population and jobs in that Roomba-shaped, Roomba-sized catchment area. And the one thing on this graphic that was just an artifact of the way we were doing a lot of different data sources is ignore the projects that are right smack along the y-axis. Those were coming from something we call batch 4 in model data. But all the other projects do show you a pattern that you'd kind of expect to see of some relationship between total time saved by the projects at a per capita level and the accessibility that each of those travelers could get to in terms of increased jobs. And they also do reflect the location in the region. So in terms of thinking about some of the things that might seem to be outliers, if you look at the two areas to the right side there, right above the number 500, there's some projects that had a great amount of time savings, but didn't contribute a lot to accessibility. And that's because those were projects that were essentially at the edge of a region. So there were a lot of travelers that were able to get through a choke point and move a much further distance. But at the edge of the region, they weren't able to actually get to that many more jobs compared to a smaller amount of time savings closer into the center of a region where there were more jobs. We then did the same thing and really looked at what were the scores then in terms of this case taking a very similar check and looking at the delay score on the x-axis and the accessibility score on the y-axis. And again, patterns are generally sensible. The scatter is generally what you expect to see. You don't expect these things to line up in a straight line because there are very different differences between what you're measuring. But again, we are seeing that same set of regional edge projects are ones that are generally getting a high delay score out there at 2,500 and 3,500 without a whole lot of accessibility increase. So again, this helps us kind of feel comfortable that we're seeing something that matches with a particular focus on auto and transit. I'm going to kind of finalize here by going into non-motorized accessibility, where we got a little creative. We did want to reflect quality of service, recognizing that pedestrian quality of service is important to good placemaking and providing access, but yet people aren't going to walk faster just because they're on a good sidewalk. So we use that quality of service as a surrogate for how long will people walk, and we know from literature that people are likely to choose to walk and walk farther where there's a greater quality of sidewalks. So we're looking at sidewalk quality as a surrogate for how far people will walk and turning that into an assumption about speed to make this all still based on a speed basis. And we had two processes to do that. The first was a systemic process that's shown on the graphic here, where we took the quality of service and linked it to the roadway classification for sidewalks that were along roadways. We looked at the number of lanes that were on that roadway and the posted speed to come up with an assumed increase in quality that would translate into an assumed increase in speed, both with a sidewalk and without a sidewalk. And there were many projects that were adding a sidewalk to roads that had no sidewalk. We also had an additional set of speed benefits for a list of meaningful pedestrian improvements. And this is really things like putting in additional mid-block crossings or putting in hawk signals or things that would really improve pedestrian accessibility as a way to promote bringing in good projects and then representing them in terms of pedestrian accessibility. And that network approach also applies to pedestrians. So for instance, in the city of Hopewell, an example in yellow on the left side of Cedar Level Road, if you put a sidewalk on that road, you are going to be able to make it easier for people to walk there. but you also have to recognize that all the green network streets around it, those are also roads that are comfortable for people to walk on even if they don't have sidewalks. So there was exactly the same kind of network analysis for pedestrians as there was for autos and for transit. A couple lessons learned. We recognized that we were working off of the NHTS validation for those decay curves, and we found that there's potential to go in a lot of different directions with some more interesting ideas of looking at how people make decisions in travel. We came up with another sort of term of art, which was sometimes we have a hatchet and sometimes we have a scalpel. In doing 400 projects, it became pretty important to pick when you're going to use the scalpel. The graphic here on the screen shows one of those kinds of examples, which was an improvement to an intersection in the city of Stanton, Virginia, where the idea was to add in a new pork chop island, and that would be something that would generally be might be assumed to improve pedestrian quality of service by shortening the total crossing distance across the north-south roadway there. Although at the same time, that same project was removing the hot right, or creating a hot right, removed from the intersection. So in this case, we said no need here to those things balance themselves out. But we did recognize there's a need for a network strategic plan to help VDOT and maybe other folks around the country as well start to figure out when to use that scalpel, how to design that scalpel so that you could bring in a network approach to this project. Probably depends upon the upstream signal and platooning of vehicles in terms of the actual net effect of the pork chop island. And for the next generation of stuff, there's looking at level of traffic stress ideas and blending the in-vehicle and out-of-vehicle time of transit are some of the things we're looking to take forward as well. This all links to the fact that at this point we're doing good things, looking just at the total amount of travel time, and we'll be considering also, are there ways to get to perceived time like that in-vehicle and out-of-vehicle time, look at the out-of-pocket costs, and do a little bit more to build upon what we've already done with kind of perceived comfort with quality of service. So we're thinking about how should these things be reflected in perhaps an evolution of smart scale. Kind of leading into where Matt will go, we think that network granularity is a great area of good promise. One of the things we found in this chart showing what the relationship was between the sugar access network of auto trips on the x-axis compared to the reported time people told us they would travel on the y-axis is, again, you see that there's a little bit of a scatter here. You know that the things in the lower right-hand corner there's a few people that said it only took me 5 minutes to make my trip, and it's impossible, so you can throw those out. But we also learned, though, that there is a way of improving network granularity by putting in the terminal time for all auto trips that we've seen. We do need to be doing better in terms of figuring out how to make the use of systemized data, because sidewalk inventory, we had absolute confidence in about 13% of the data. So a fair amount of the quality control was looking at these project locations and making sure that we were doing QC on the automated data to be comfortable that it actually reflected the sidewalks that were there that the applicants were proposing to build upon. But again, I think there's a good promise here to continue to move forward in that direction. Lastly, accessibility is very helpful for VDOT in thinking about the smart scale project scoring, but it can also lead to some things that are a little bit more kind of placemaking and other performance measures, like a linkage between accessibility and vehicle miles of travel that we looked at for 2040 for the Washington, D.C. region, as well as predicting mode share. It's a pretty effective tool and some strong relationships that adjust the travel time for multimodal accessibility, and the relationships between what you can get to by different modes helps explain mode share and travel behavior. And so I'm going to turn the floor over to Matt.
Unmuted.
To take you more under the hood with sugar.
Okay, thanks, Dan. And I think we are running a little bit late, but I do want to assure people we're not going to cut you off at the top of the hour. And also, if you do have to leave us, we will have the slides and the full recording up on the up on our website tomorrow at ssti.us, and we'll also have contact information for all of our presenters. So if for some reason you have to stop before we get to your questions, you'll be able to get that information and contact them directly. I also just wanted to let you know that there was all of our webinars are up on our website. So if you wanted to look into sugar access and accessibility or smart scale, those webinars are also up on our website under the events tab. So you can go back and look at those as well. So Matt, you should have control of the slides now, so I'll let you go ahead.
Muted. Perfect. Thank you, Robbie. And I promise I will stick within about 10 minutes here so we can leave time for questions later. See, Robbie, okay, looks like it's working now. Thank you. So my name is Matt Pettit. I'm a product engineer with Citilabs, specifically working on sugar access. So I was really involved with making sure that sugar access worked for Virginia and for Renaissance, and it really allowed them to score 400 projects on accessibility within 1 month. So I just wanted to spend a little time showing exactly what it took to do that. So it starts with the data side, and Dan had talked about the roadway information coming from here. So in order to do that, we look at two different levels of data. We have high-level data in terms of a statewide network, and we also have a lot of regional networks to look at more transit and pedestrian type of projects. For that roadway, those roadway projects, Dan was talking about having a 45-mile buffer around the project, as to understand what the impact of that project is. So if we're looking at a project near the edge of the state, that means that impact could extend over state lines. So we actually had to go in and get 5 or 6 states data to build this full network and understand the impact of someone who might live next to the border, and maybe that project benefits them to get to projects outside the state. So the HERE data really allowed us to scale this across, not just Virginia, but other states which impacted the accessibility. And then diving deeper, looking at transit and pedestrian projects, we had to build a more detailed network utilizing additional roadways or pedestrian paths, bike paths, to build a full multimodal network, which also consisted of a transit network. So if we look at the little map that's cut out here, this is Blacksburg, Virginia. We have our detailed pedestrian and roadway network, as well as the transit network, which is coming from the GTFS. So gathering all this information, we really get that granularity of travel, which Dan showed. So the next thing was, we didn't want this to stop with smart scale. We wanted to apply it to other processes, let other organizations within Virginia utilize this tool. So we've also started creating things such as this web app, which is available for all the government organizations within Virginia. They can go on this website and see the region that they are in and understand the data that they need to do this work locally. So they'll be able to connect with the Virginia DOT to get the correct data and analyze accessibility locally moving forward. Dan had also mentioned that we don't want to really look at the accessibility of yesterday or the accessibility of today even. We need to use data such as economic forecasts for population and employment to understand when these projects are actually built, how this will change accessibility. So the potential issue with this is that this could be a traffic analysis data. This could be census block group, parcel level data. We can get data in any different formats as we go from state to state and how states or local jurisdictions really differ in developing this information. So within Sugar Access, we really tried to make this scalable and allow any type of data that local governments had, state governments had, to bring in order to do their accessibility analysis. The next was when we were looking at keep on moving along this process from 2015 to 2016 with the Smart Scale process, is that we wanted to look at more types of trips. We wanted to look at auto, transit, walk trips. You know, hopefully next time it's also bike trips. And so in order to do this, we don't want to be able to have to analyze every type of trip or every type of travel mode individually. This creates a lot of different processing that we need to do, a lot of different analyses that we need to do. So we need an easy button. So within Sugar, we really leverage the ability to look at all types of modes at once. And when we do that, we get all the different accessibility scores for each individual mode. So this really streamlined the project team and doing their post-analyses, coming up with the rankings for all these modes that they were going to look at. So the next one is leveraging cloud processing. So when we talked about, being able to analyze 400 projects, how are we going to do that? Do we have enough computing power? Can we run this on local machines? If this starts being controlled by local governments and local organizations, can they even run it themselves on their own computers? So that's when we started looking at, Amazon Web Services and leveraging their computing services, their processing power to not only run these analyses faster, but also run them in parallel, which really enabled us to, once we've kind of gathered ourselves and knew what we were doing moving forward, that, once we built that system, we just ran all these projects, and once we get them back, we were able to start ranking them. So that really helped us speed up this process and really makes it scalable in the future. And then going back to also what Dan said about decay functions, which are, value of time curves. These may differ per geographies. They also may differ per trip purpose. So as we move forward, we're starting to look at not just home-based work trips, but also home-based non-work trips, as trips to education, trips to medical services. So within Sugar, we really wanted to allow the client, allow the local government planner to have that information available and then be able to run their analysis in their local area. And the last capability that we wanted to look at here is really the project analysis itself. So if we're talking about analyzing accessibility, we're talking about a change. It could be either in the travel times, the speeds on the roadways themselves. It could be, Dan also talked about, the walk level of service. So we could be talking about a complete streets project where now that level of service for walking is much better. But we could also be talking about, adding a new roadway, adding a new transit line. There's all these different types of projects that we need to analyze. So in order to empower us to do that, we've created a flexible system where both we can, if it's a simple change, such as improving roadway travel times or walk level of service, then the user can depict this within a table of what those changes are, to what areas are they applied to, and then we can run the analysis within Sugar to get that answer. But it also might be a case where, there's a lot of smart scale projects that were transit oriented, or also ones that were creating new roadways, and it's a much more complicated change. So within Sugar, we're also able to leverage the Sugar network editing tool to add new transit lines, add new roadway or pedestrian paths. So here we are actually looking at one of the projects from the the smart scale process in that we improved the travel time for this transit route, but it wasn't necessarily applying that through the whole route. We had to specify a specific part of the route in which the travel time was improved by having exclusive right-of-way. So it's these little nuances of the project that we want to make sure that we had right in order to get that correct score for ranking the projects. So with that, I want to turn it back over to Rob.
Unmuted.
Some time for more questions.
Thank you, Matt. And I, again, want to emphasize that we do have a webinar all just on smart scale and one on accessibility and sugar, both available on our website. So if you want more information about either of those, you can access it on our website. The recording of this will be up on our website tomorrow, along with the slides. So again, you'll be able to contact any of the participants if you need to. I'm going to let my colleague Mary Ebeling, who has been sorting through some of the questions, go ahead and ask those questions. But I do want to say if you need to ask a question, you can go ahead and type it into the chat box. We'll just go ahead and answer for at least a few minutes after the hour. And you can subscribe to our newsletter and follow us on Twitter at ssti.us and find the webinars and the slides up there as well. Okay, Mary, what kind of questions do people have?
All right, thanks, Robbie. Well, we have a couple of questions about, I guess I will just read, there's two questions about induced demand. So in determining increases in speed resulting from roadway capacity projects, how do you factor in induced travel that would precipitate from the capacity increasing project, or the roadway capacity project? So for both the actual location where that project occurred and beyond the improved section of the facility.
Well,
so,
it's funny.
Go ahead.
I'll jump in, and I think that what we've got, it's a great diverse group of analysts, so we probably all could answer many of the questions. Real quickly, one of the things that VDOT did do was to consider the extent of the project itself in terms of what type of tool was used to consider congestion. So small intersection projects, sidewalks, no induced demand was considered. But for major projects, regional travel demand models were used that did reflect induced demand. And part of the challenge then in accessibility was to use that actual network result to say that some places you might actually see a particular OD pattern could have had reduced accessibility, but it might have been offset by other OD patterns having increased accessibility. And we also did, in looking particularly at park and ride lots, in the benefits of park and ride lots, we did, basically use some thresholds of, if we had more than 15,000 VMT being generated in terms of potential benefit in terms of reduced VMT because people were leaving their cars in the park and ride lot, we tended to apply. We set up a process for looking at induced demand for those few projects that could generate induced demand, but were not explicitly analyzed using a travel demand model.
Okay, anybody else? All right, we've had a couple of questions about data and the size of the analysis zone. So I'll start with the geography. And I think we've answered this, but maybe the person who asked the question joined late. What level of geography is used, parcel census block or TAZ, traffic analysis zone? I think this would be helpful just to get it out on the question answer record.
Yeah, I'll jump in again. And basically, it was a census block for transit and pedestrians, and then the block group for auto.
Okay. Yeah, and that really goes with the different levels of the networks that we created. So we wanted to create a statewide network, and we utilized census block groups or TAZs for that analysis. But when we were looking at a much more detailed regional network with pedestrian paths and a transit network, then we wanted to really get into the nitty-gritty and look at census blocks.
Okay, thank you. And then this is a data question. What is the base source of sidewalk coverage for the road network? Is that coming from the city's inventory?
It's actually coming from a statewide inventory, and I have to admit myself, Matt, you might know how that state sidewalk inventory got developed from individual sources, or Chad might have more input on that.
We have a statewide database here in Virginia called the Statewide Planning System, and that includes physical characteristics of the road network, including information about the presence of sidewalks, whether it's on both sides of the road, one side of the road. And I believe data from that was used sort of as the basis for establishing the walkability, looking at the pedestrian access as part of the accessibility. So we were able to query that data set and provide that information to the Renaissance team.
Okay. Thanks. Thank you so much. This is our last question, and we're almost out of time, so it's perfect timing. This is a question for Dan. Can you explain why the walkability map showed wider access than the auto map?
Yeah, I think that's maybe just an artifact of the fact that the scales, we were looking at patterns there, but in that slide that showed auto, transit, and walk, basically each of those scales is off by about a factor of 10. So it wasn't that you could actually get to more jobs by walking than you could by auto or transit, but the message from that was how important walking is throughout an urbanized region, that unlike auto and transit, it's not just the downtown jobs that can be better accessed with improved pedestrian connections.
Okay, well, that is actually our last question, and I'm going to kick it back over to Robbie to make a few comments.
Unmuted.
Well, thank you, Mary, and thank you everyone for joining us. This was a lot of information, just fascinating, both smart scale and the work that's being done on accessibility. These are both really cutting edge projects and ways of looking at transportation. So I want to thank all of our participants for helping us understand these and for giving us so much great information. Again, everyone who's on the webinar will receive an email with a link to the recording, and you can find all of our webinars up on our website. You can subscribe to our newsletter, and you can follow us on Twitter and find all kinds of great resources up there. So thank you to everyone for joining us, and thank you so much to our presenters as well.